go back to your other sheet where it says which one's which?
Sure. Did I do something wrong?
On the other one, I'm confused because I got the opposite of you on the last two.
Did you combine the like terms on this one to get it 1x to the 5th?
Yeah.
So positive, odd. Okay, so did you write your infinity first or your negative infinity first on your x?
Or negative infinity.
Maybe Mrs. Hooper can look at yours individually. Yeah.
Sorry.
That's okay. Maybe I did something wrong.
Isn't it when you're combining? No, that just changed the number. I was wrong. I was combining the exponents and making it 10 to the 5th.
Oh, yeah. You got to be careful. Yeah. Anyone else? Yeah.
I just have more specifically a question for D. Well, I looked at it originally and I was like, okay, I know those two terms are the same exponent, so I just picked the one with the bigger number. Does that always work, or would you
No.
have to combine like terms every time?
You have to combine like terms every time because what if the bigger number, like if this one was a 1 and that's a 3, when I had combined them, it would have been 2. Oh. Because that one doesn't matter if it's even or odd. You know, I don't know. I don't know the answer to that. Let me think about it.
If it was -4.
I don't know if you could just pick the bigger one. I don't.
It would work if they had the same sign, but because one's negative and one's positive, I assume.
I think that might work each time, but that's a great question. I've never thought about it. So before I give you,
I got the same answer, and I went back and I did it the way.
well, because when I said no, I was thinking that it mattered if that one was even or odd, but that doesn't matter. So let me think about it before I give you a for sure answer. That's a good question. I haven't thought about it before. Okay, anyone else? Okay, we're gonna move on to the next part here. Now you guys are pros at end behavior, right? Like super, super big pros, right? Yeah? So, is it fair to say that if something is raised to the power of 4, the two ends have to go in the same direction? Right? If something is an x to the 4th,
Yeah.
then it has to have something where the two ends either both go up, up, or down, down, right?
Yeah.
Okay, what if I had, what's the most number of x-intercepts an x to the 4th power could have?
2.
4. Because what if I have 4 factors, right? Here's what I want you to try and draw. I want you to try and draw for me a 4th, something that has 4 x-intercepts, ends in the same direction, but has 4 turning points. Try and draw that for me. I want you to try and draw for me something that has 4 x-intercepts, ends in the same direction, and has 4 turning points.
Can you write down what you just
Sure.
said?
That's either. Wait.
Anybody got it? I'll give you a whole bag. Oh, you do? With 4 turning points? Oh, I can. Okay, can I see you? Do you want to come draw it?
Well, actually, you have 4 turning points.
Oh, it has 5? Uh-oh. I was about to say I'd give you a bag of tickets. If anyone has it, I'll give you this.
Oh,
A bag of tickets.
that's impossible.
It's impossible. What? It's impossible. I only have 3. That's the whole point, our next pattern.
But I could make
If you look here, could I ever have, you don't have to turn back, just look. Could I ever have a parabola x squared with more than 1 turning point? No. Okay? I can have a x cubed with 2 turning points. I can have an x to the 4th with 1. We saw one here. You guys just tried to draw for me one that had 4 x-intercepts. But if you got 4 x-intercepts in, how many turning points did it have?
3.
Okay, find me a pattern. What's the pattern? Put it all together. What's the rule for turning points? Anyone?
One less.
Yes, one less than the degree. Good job. The maximum number of turning points is always one less than the degree. What? That's not a G or a D. That's a G. Okay. Yeah.
What that means is like it can have that many, but it won't always have that many turning points.
Exactly. Look at this one here. This is a fourth degree with 4 distinct x-intercepts. 4 different. Distinct means different. But we graphed one here. Not there. Not there. We graphed one here that only had 1, right? So the main rule is that that is the most possible amount we could have. And for even degrees, we'll always have an odd amount. And odd degrees will always have an even amount. Right? But so a 6th degree could have 1 turning point, 3 turning points, or 5 turning points. 5th degree could have 2, none, or 4. Good. The whole point is that by the end of class today, in like 12 minutes, okay, we are going to be able to get a pretty good idea of what each of these graphs is going to look like without a calculator and without graphing it, just based on what is A and what is N. Make sense? Okay, how are we doing, okay? Okay, I got one more concept, and then we're going to try some examples. It's known as multiplicity. What a fancy word. Okay, this page I keep skipping, let's go back to it.